Hello, it's James here. This is a bit of a different video. This week I'm going to talk about my walking robotic history, and that's because I've got a big secret project on that I've been busy working on. So OpenDog is very much still ongoing and it's being a table at the moment, but there'll be some more on that later this year and next year when I do all the upgrades that I mentioned in part 13. But for today we're just going to talk about how I got into robotics and look at some of my older projects, because quite a few people have asked me, how did I learn to do all this stuff? And all of those sorts of questions. So we're going to go right back in time, all the way to 2004, but not my childhood. Yes, I now have Robot X t-shirts in my t-shirt store. Check out the link in the description, as well as OpenDog and all of the other merchandise. So I had a bit of an education history in computer-aided engineering and electronic engineering and stuff like that, but that was in the 90s when they didn't even teach us about microcontrollers. So I worked in IT for a bit, and then in about 2004, I decided I wanted to build robots. Why not build a human-sized walking robot? That can't be too hard. So I searched the internet of what it was then, 14 years ago, to see if there were any good tutorials on how to make a human-sized walking robot really cheaply. And of course I found there weren't any. So I decided to make a website, work out how to do it, and write the website and put all the information on there. And I registered XRobots.co.uk, which is still my website now, that's got a blog of some of the projects, mostly links to YouTube videos, and a lot of other pictures, so you can check that out. And if you go onto the older Android projects, you can find some of my old builds, which we're going to talk about today. There's pages and pages of it, because I've done about 10, trying to make a robot that walks along that's human-sized, which I've sort of vaguely achieved. So let's have a look at Android 1. So, of course, this is before YouTube, so there's no videos of it, I'm afraid, but the first one was made of wood, and I decided to simplify the legs by making this sort of scissor lift mechanism that I planned there with paper. It's before CAD, before any 3D CAD at least. I'd done a bit of Autodesk at college, but there was no sort of like easily making linkages like you can now in Fusion 360, so it's all planned on paper, and then I basically built it out of wood with like studding that I still use now, and wood and bits of aluminium tube to make joints, and made these parallelogram legs. The plan was they were going to be pulled up by cordless screwdriver motors, I think, which cost £4 from a DIY shop each, which were nowhere near strong enough, and I think it had bungees in it, which are still used in projects, which basically pulled them down. And the plan was it had this sort of cradle that swung side to side in its body, which contained a full-size PC, not even a mini ITX board, and the power supply was behind its head somewhere because there's nowhere else to put it. It was going to swing its mass side to side and somehow pick up its legs, and I think it had rotating hips that were going to make it put one foot in front of the other. And the plan was to run Visual Basic 6, probably on Windows 95 or something, on this desktop PC that sat in its body that was going to do some timing. But needless to say, it was massive. It turned out to be nearly 7 feet tall, wouldn't go out of the door, and it was just too heavy to lift itself. So I decided to make a lighter one after that, and that's Android 2, which is made out of aluminium. Android 2 had a bunch of different joints. It had a joint with a motor on each joint, which were made of the same cordless screwdriver motors with, I think, T5 pulleys on. And then I had some belts, which I turned inside out around wooden formers to make big tooth pulleys or gears or whatever, which kind of almost worked, although they didn't really mesh properly. And the feedback on this one was actually feedback pots. But in order to get a reference voltage, I used servos turning a potentiometer to make loads of analog voltages from a serial servo controller controlled by Visual Basic 6, which ran on the same onboard PC, and that analog voltage was compared, I think, with an op-amp, which then switched a relay either way to control the motors. Now, there's some video of this hobbling along, but I can't find it, unfortunately, but it's really grainy old footage. Again, this is about 2005 or something, before YouTube, and before we had, like, smartphone cameras or anything like that. So I don't even know what I filmed it on, probably a dodgy webcam. It didn't take very big steps. It could lean side to side, and it did almost hobble along. So I decided then that maybe making it human size was a bit too tall. So let's make something stocky and really rigid. So we're back to the wood again, and Android 3. So Android 3 was the first Android I built that actually had parallelogram legs, and this is probably going back to about 2005 or 6. I got through these Androids quite quick as I worked on them every day. So somewhere around there, maybe 2000, late 2005, something like that. So that's where the first ideas from Robot X and some of those other robots came from. So this is wood that's been painted up with some nice glossy car paint. Thought I'd put some attention to finishing on there. And essentially what I did was synced up the hip and the ankles with bicycle brake cords, which are basically Bruton cables, which is a cable in a tube, and that kept the hips and the ankles parallel, which isn't really what you need for dynamic walking, but it worked all right. And I actually spent some money on motors this time, and I bought some of these Como Drills 914 motors, I think they are, with gearboxes on the end, and they were quite expensive at the time. They're about £25 each, and I think there's 4 or 5 of them, and some of them pull kind of cables, steel bicycle brake cord again, and I made some pulleys out of washers, and again we had positioning for those joints with feedback pots and some sort of comparator. Can't quite remember what the electronics were, but essentially again I'm using servos with a serial servo controller to turn pots to make a reference voltage. We're going to talk a bit more about another way I did that in a moment in some of the later projects. And this Android did walk along. It is very slow because I got sort of the powerful motors that were really geared down. They weren't really coupled properly to the joints, so it was a bit loose, but it did take a few steps. Again, there's no video. It was before YouTube. Not sure if I ever took any video. I might have had kind of a camcorder with a tape in then, but yeah, not really sure. This is Android 4. Android 4 was pneumatic, and that's because I found an educational website which is still going called Mindsets Online in the UK that sell all sorts of educational stuff. It was called Middlesex University Teaching Resource back in the day, and they sold these sort of cheap pneumatica kits, which was a piece of pipe and you assembled it yourself, had some injection moulded ends, and you had like a plunger that went in the tube made with some washers and some threaded bar and some O-rings and things. You can make your own really cheap pneumatic set. But pneumatics are pretty powerful. I think it was recommended you didn't go over 2 bar. So I built this robot with steel tubing and wood and stuff. And the pneumatics with 2 cylinders on each leg, again parallelogram legs, those are more than strong enough to push it. And it felt like it was going to work really well, but unfortunately pneumatic valves are really expensive, the solenoid ones, so I just opened the tap manually to see if it was going to work, and I couldn't afford a compressor either, so I just had a foot pump and a plastic lemonade bottle to make a reservoir. So didn't really get much further with that. If I had it now though, then it probably would work quite well if I actually had a compressor and could sync up some solenoid valves. I had quite big feet, I could probably make it walk along. So after that I decided to go back and do another electric Android. So with the sloppiness of the last motors, just sort of like pushing levers on the parallelogram legs in Android 3, I decided to stiffen it up a bit, and this time I decided to make my own linear actuators, again using the cordless screwdrivers because they had a hex chuck that I could file down the studding and put in the chucks to hold it. And I made these linear actuators, but this is really before you could go on eBay and buy cheap lead screws and ball screws from China. So I just used studding, didn't have any smooth rails, so it actually slid on studding as well, which is pretty nasty. And I went back to that parallelogram leg design, but this time with 2 actuators in the top and 2 in the bottom that also did the hip and ankle joints. And this is pretty much exactly the same layout as Robot X, just made out of wood and not really suitable parts. And it did work. It was very slow. It could stand on one leg, but I think what happened in the end, the linear actuators jammed either because the nuts come undone or the studding jammed and loads of the motors produced smoke, and that was a terrible idea. But I did build my first control system for properly positioning linear actuators and joints using an analog voltage. So let's have a look at that. And here it is, which is a rather lovely ham-wired horrible looking thing, which is sort of held together with its own wires at the back. No 3D printing then, so no nice enclosure. You could probably get a project box from Maplin or something, but there we go. So what we've actually got here is 8 pick chips, although they're actually pickaxe chips, which are pick chips with a bootloader on from a company called Revolution Education, which means you can program in BASIC with only 2 resistors to download the code. It does mean that there's only software serial that runs at 2400 baud, and all of these are on a common serial bus, which was originally controlled from another pickaxe chip. So that actually meant you could almost see the lag in the data being software serial as well. And this controlled 8 motors. Each one of these pick chips is responsible for 1 motor. And in fact what it does is receives a value over serial. They're all on one serial bus, so they've each got an identifier, then they receive a value, and it outputs 8 parallel digital pins for that value, which is what all these wires are going to the other half. On the other half there's 8 digital to analog converters, each with its own op-amp follower there to get the actual analog voltage. These are DACO 800s. So 8 digital bits to 8 digital bits to 1 analog voltage comes out of here, and that then went to a comparator circuit, the same as the previous one, which was a whole other thing, which was like this. And this has got some op-amps on and some other bits and pieces that compares that analog voltage from here with the feedback pot on the joint, and then it still switches a relay, so there were no cheap motor drivers you could just buy for £10 that would handle all that current. So I've got 16 amp relays, 2 pairs of them to make relay H bridges, each one of these controls 2 motors. So in the robot with 8 motors, there were 4 of these. These I actually etched my own PCBs as well in the day by drawing on copper clad board with an etch resist pen and throwing it in ferric chloride in the kitchen and stirring it round till the copper etched away and then hand drilling all the holes. So yeah, there was no iron-on toner transfer or cheap companies to prototype your PCB back then, 2006 or whenever it was. Or there may have been, but I just wasn't aware of them. So that's that. So 4 of those, and that's how it controlled all the positions. But now I can control 8 motors over serial with microcontrollers, which is a lot better than Visual Basic, doing some controlling servos to make an analog voltage and all of that. So now I can control 8 motors at 16 amp each. I decided to use windscreen wiper motors, which is still a favourite thing that I use today. This is going back a few years though, probably 2005, 6, something like that. So I built Android 6, which was all plywood and studding and it's a bit heavier duty. It had a bunch of windscreen wiper motors in it, and basically that's how it worked, and it was fairly large. I added arms to it at one point and it went through several iterations of upper body. Here's a picture of it in my old kitchen. It was pretty big and it weighed quite a lot, like the projects that I build now really. It did walk along though. There's video of this one in my YouTube channel. You can still find these videos. They're some of the first videos I ever uploaded in about 2007, but the video was taken a few years before that. It's just YouTube didn't exist, or I didn't have a YouTube account or whatever it was. And you certainly couldn't make money out of YouTube in those days. There was no Patreon. There was no funding for any of this. It was all paid for out of my own pocket because I had a day job in IT. So yeah, have a look at my early videos. You can see some of it sort of walking along there, actually taking steps with all of those joints coordinated. And you'll notice a pool of light in the corner, which is light bulbs to sync current from an old server power supply because it wouldn't turn on otherwise. So the power's coming along long leads to run the wiper motors, which are 12 volt on 5 volts from a big old power supply, so they go slower. So no speed control, of course. And moving swiftly on, this is Android 7, which sort of worked even better actually. It definitely walked quite a lot better by twitching its hips. A bit more like a human to take steps, and this one actually only had 3 motors in. Had 3 wiper motors pulling cables against bungees, had 1 in each leg, and a sort of clever arrangement of cables and a switching kneecap that meant it pushed the bottom of the parallelogram leg back when the top of it pushed forward, but when the top pushed back, at least the bottom stayed there, so it kind of bent its knee. And it had another one that pulled it side to side with bungees, and it was all strung up quite tight. It was quite hit and miss, but it did take steps. And there's more pictures of this on the website as well. And this was kind of like, with just those few things, few motors and some rudimentary position control, this is pretty much the best I got as a walking robot. Now, Robot 8, or Android 8, wasn't an Android at all. I did a rudimentary 3D design to try and work out how I'd make a wheeled robot with an arm on, so I'm not going to talk about that one. Didn't ever build it. Might use some of the design aspects in the future, but I can probably do something better than I did in 2007 or whenever it was. So moving on, we're on to Android 9, which was basically made of balsa wood. And I decided to go back and use really cheap motors, so there's some plastic Tamiya gearboxes. And they had, again, 1 on each joint. I think I had parallelogram legs in that one. The whole thing was made of balsa wood and cardstock. Again, pickaxe microcontrollers. But this one, actually, importantly, had some sense of dynamic stability. So I had a helicopter gyro there, which produced a PWM signal for controlling servos. And that was actually read by the microcontroller. And that altered the timing of the steps side to side so that it didn't overbalance. And this is one of the first things I made that actually had some sense of dynamic stability. It didn't work very well, and I never made it walk, and I don't think it was very strong, so it was kind of more flexible than I expected it to be for some balsa wood glued together, surprisingly enough. It's funny how mass builds up when you make these things bigger. So that one was abandoned as well. But then after that, we're now on to Android 10. This is Android 10, which is the first one from the past that I've still actually got, and it's been lurking around in the background for some time. You might have spotted it in the other videos. And this one is made from Shape Lock, or Easy Plastic, which is a plastic that you can mould in hot water at about 60 degrees. And essentially it's all made of that plastic, apart from a few bits and pieces. I believe that I use curtain poles and curtain rings and some doorknobs and things which are in there, which basically make ball joints so that all of the joints move. And it's all strung up with bungees. I've used motors which are, again, cordless screwdriver motors. They've got bearings embedded right in the ends of them there to hold them, and some of these are set up as pulleys. So you can see there's a pulley in there with a lovely polymorph dodgy pulley with strings that go round. There's some of this is bungee and some of it's cord, so that the joints can bend. So you can see its knees bending, and also we've got these end switches which get pulled when the string is pulled tight, so it knows where the end is. So this is kind of a bit experimental. It's got a flexible spine and some other things, and I plan to put arms on in the end. But essentially, I never put any electronics or control in, so I've no idea whether it would have worked. I have a feeling the motors might have had some trouble pulling those strings around the dodgy pulleys. This is well before I had 3D printing. That was the best way to make plastic parts at the time. So it's a bit experimental. I think it got featured on Engadget at some point, actually, on the blog. But yeah, never powered it up, abandoned it, and went on to do something much more sensible, which we're going to look at next. Yes, this is Android 11, which you'll notice from the leg profile is a small version of Android 6, of pretty much exactly the same shapes cut out here, just in styrene instead of plywood. So this one is driven by servos. It's got little radio control servos in instead of the massive wiper motors we had in Android 6. These are pretty cheap ones. These are actually clones of the Footabar S3003, which are about £2.50 each from China. So we've got on here to some point when eBay exists and you can buy cheap stuff. So that made it quite helpful, although obviously still no funding. I had a YouTube channel by now, but wasn't making much money, about 2p a lifetime from ad revenue, I think. So most of this was still, of course, funded out of my own pocket. I would have used better servos if it were for Patreon and things like that, but there's nothing like that in those days. The other materials in here are some aluminium. All of this is handmade, of course, before 3D printing. So we've got aluminium that I made in my shed with a file and a drill and some M4 studding cut with a hacksaw, and I've got these chocolate blocks here which basically are pretending to be the joints, so they work okay, I guess. There's some flex in them, and some really thin wire from radio controlled aeroplanes operating ailerons and that sort of thing. So it's got 8 motors, and it's got ankle joints, and it's got hip joints. And the innovative feature of this was it was dynamically stable. So originally I had a bunch of RC heading gyros attached to it, and there was one for each servo. And essentially you wire those in line with the servo, and as they move through space, they'll affect the servo position. So I was originally using a pickaxe chip again to send fixed positions to the servos, and then that went through an RC heading gyro, all oriented for the different axes that the servos were mounted in, and then that RC heading gyro would alter the position and it'd make it dynamically stable, so it didn't build up inertia and overbalance. And after some experimentation, I actually got that to walk quite well. It does tip its mass side to side quite a bit. It's not much like Android 7 where it just twitches its hips side to side, but nonetheless it was under control and it was fairly repeatable. Obviously it's quite small, and I used these servos, which just about had enough power, and then I decided this was great, dynamically stable on every axis, so let's scale that up and make Android 12. So then I got a 3D printer, which was the start of everything that you see in my channel now, really, and learned to do 3D modelling. So this is Android 12, which is almost entirely 3D printed, apart from some studding and some bits of smooth bar. And this has got much better servos in it, so it's got some 15 kilogram centimetre torque servos with metal gears, and these are actually driving belts, which are driving some linear bearings on some smooth rod, and we've got integrated feedback pots for that linear motion. And essentially I ditched the parallelogram leg design, which is a really bad idea. If I'd kept that, it probably would have worked much better. But again, it does have independent hip joints, but no ankles this time. Those are just passive hinges. And they've got the actuator on the knee and the lower leg there, and that's about it really. So again, this is actually attempting to do dynamic stability with the RC heading gyros that I've got there, one for each servo again, but basically this didn't work quite as well, partly because probably missing that parallelogram leg design, having no ankle joints, but also the actual heading gyros, you can only adjust the sensitivity a certain amount, and that sort of dynamics fitted quite well with the smaller robot, but it doesn't fit so well with the taller robot, the sort of natural coefficient of that compensation. So this didn't work quite as well, and I sort of gave up building walking robots for a while, until a few years later when of course we moved on to Robot X. But wait a minute, I almost forgot my Star Wars walking Gonk droid, which was actually the first walking robot I made, which used an Arduino and an inertial measurement unit containing a gyro and an accelerometer to stay stable. This was actually dynamically stable, it could balance as it went and stop itself overbalancing and so on. All of those joint positions were modified through one inertial measurement unit and a bunch of PID controllers. And of course we're into the modern day here, so we've got a good YouTube channel, I've got Patreon funding and things like that, so I can afford all the motors, although I use quite cheap small ones in the end, and 3D printed gears for this robot. But basically it means I can get proper motor drivers, so it's full of BTS 7960s. I think there's 8 or 9 of them altogether, and on the whole the results are pretty good. I built a crazy remote that's Bluetooth controlled, so it's serial over Bluetooth, and I've got lots of knobs I can adjust there, the pitch of the feet and things, so I can make it sidestep a little bit and try and stay on track to walk in a straight line. That worked pretty well in the end. And now back to Robot X, which of course was the next generation on. So I actually paid for really good actuators in the end, which were around £100 each or something, as opposed to the little motors that I had in the Gonk droid. Originally with Robot X I tried out using lead screws in cordless screwdriver chucks, which was good to see that it was going to work. Then I did that upgrade and spent the money a bit later on, of course, using Patreon funding to fund the projects, which is why it's really good to fund channels on Patreon, because you know that then there's some budget to actually fund the project. And the same goes for OpenDog, of course, which is the next step on. So Robot X is using an Arduino Duo, which is 80 MHz and 32 bits, so we've sort of lost the 8-bit microcontroller there, although I've actually put one back in OpenDog for testing, and that's going to get upgraded as well. And Robot X is made of aluminium, and it's made of 3D printed parts, it's got arms, and it's done various stuff. It's dressed up as Bender from Futurama, it's also dressed up as Spider-Man, and also it can breathe fire when I did the collaboration with Look Mum No Computer. But this is a full series in the channel which you can check out. I think there's 12 videos or something like that, and basically the next step on is to go for more legs to try and get a much more dynamic, faster walking robot, and that's now the current project, which is OpenDog. So if you're subscribed to the channel, you'll of course know all about OpenDog. The last video in the series was up last Tuesday, where we added an inertial measurement unit and tried to make it dynamically stable, which didn't work too badly, but we really need to upgrade those 8-bit micros, and it's probably going to be Teensy, which is an Arduino compatible processor running at 180 MHz, which is 32-bit. So hopefully that should solve some of those lag issues that I've got with all the serial buses strung together and the 8-bit precision, which may account for my kinematic model being slightly inaccurate, which we looked at in the last video. So to go back to answering the original question, how do I know how to do all this stuff? Basically, it seems that I've just tried to do it, worked it out through trial and error over the years, and got a feel for it, and that's how I've done it. And every robot I've built's got slightly better, using slightly better components. In the OpenDog project we've got the ODrive robotics drivers and the brushless motors, and therefore the code is going to have to be a bit more complicated. And I guess originally I started building these robots to be better at writing software. I'm still not that good, but actually I can make it work. Arduino has come along within that time frame pretty much, as well as YouTube and being able to buy stuff on eBay and get these components, and of course electronics development. Companies like ODrive Robotics, Adafruit, SparkFun, all those companies who've got modules that work with libraries with Arduino makes it a lot easier than it was even 10 years ago to build something and to find information out on the internet. And of course I've produced lots of other projects along the way, Star Wars droids, lots of BB series droids, which of course are dynamically stable as well using inertial measurement units, and pretty much there's been a video every week for about the last 5 years. So regular videos come out on Tuesday, and some people ask me how do I actually have the time and manage to get those videos made, and mostly I make the things right first time. And the main reason that I've managed to do that is just by accumulating experience over the years, knowing that the mechanism I design in each one is going to work, and therefore there aren't too many times I have to go back and do it again and waste time. And that's really the only way I've managed to get the projects out every week. And of course 3D printing on a lot of 3D printers at once, and the CNC machine and all these tools help as well. So I hope you've enjoyed that roundup. Don't forget to check back next week, all being well, for the big secret project, which is another robotics project. And don't forget you can fund me on Patreon, as well as getting your t-shirts and other merchandise. So have a look at patreon.com/XRobots, and you can get access to some exclusive rewards, including a live stream with me and all my videos early. Alright, that's all for now.